Now let's look at how to apply the regression equation that we have determined and we've tested whether it is significant or not. Now, how do we set this up for forecasting into the future? Okay. Now, as I mentioned earlier, to forecast into the future, we need to have a value for x, and if that x is not available to us, then we have to forecast the x and then compute the forecast for y, and this increases the variabilities. Okay. But of course, if you don't want to forecast x, we can make up several possible values for x and do a kind of a what if analysis. Okay. Now, but in any case, so we need to have a way of knowing what the x is. So there are three ways where how it can be done. One is if you know x already, okay, which will be the case if you are doing a lag kind of thing. If you have a lag kind of thing, so you have the x value this period, which will affect the price next period. So we have the actual value of x now, so we can use it for predicting, or we can forecast what the future unknown value is. If x is unknown, then you try to forecast x, or we can make up x values, of course, in a educated way, not just simply make it out of thin air, and do a what if type of forecast. So whatever the case may be, so let's say x for the next time period n plus 1, okay, we have found the x value in one of those three ways. Then the point estimate is given by b sub 0 plus b sub 1 times that x value. So that gives you one forecast for that future time period. But what we want is not just one forecast, but we want a forecast interval. So for that prediction interval, then we have to take that point forecast and multiply by a margin of error. The margin of error is given by t table value multiplied by the standard error of the forecast error. And this is given by this formula. So you have s times square root of this. Okay, this kind of looks menacing, but it's easy enough to set up. So let's set this up in Excel now. Now the same problem like before, dependent variable is price of gasoline per gallon unleaded, and then x is price of crude oil per barrel 1 month prior. Okay, so that's y and that's x. Let's get some of this information from the previous sheet. So b sub 0 is equal to, go to the previous sheet, and here is b sub 0. Okay. Copy that down and go one down, and n is there, and sum of x is right next to that. So if we copy down one, that will give us sum of x, and x bar is right there. Okay. Now SSX is that part. So that part is given by the denominator of the b sub 1 value, or in other words, we can do so that's the denominator of b sub 1, and s is, we calculated s right there. So all of this information is needed to set this up. So we need a 95% level of confidence, and the t table value is t dot inv dot 2t, and 1 minus confidence level will be alpha. Confidence level is 1 minus alpha, so alpha is what we need here, and degrees of freedom is n minus what? N minus 2. It is MSE degrees of freedom. So n minus 2. So that's our t. So now we want to compute the prediction intervals for the holdout sample, and then see how our estimation does with respect to the forecast error measures that we have seen before. So let's assemble the y and the x values of the holdout sample. So that is, we can just, it's there down here, and we can just set it equal to the cell address. Now here I have added that last piece one more time for computing the MASE and Thiel's U. We'll talk about that in just a second. So here is where the holdout sample starts, January of 2009. Okay, so that's January of 2009. You copy that like that. Now you copy them down. Okay, so that's our holdout sample. Now we set up the prediction interval. The forecast is B sub 0, and make that absolute reference, plus B sub 1, again absolute reference, times the L1 crude. Okay, so that gives us the point forecast. Okay, now let's set up SE of the forecast error, which is this. Okay, so we start with S, okay, make that absolute reference, times square root of 1 plus 1 over n, okay, that n must be absolute referenced, plus, okay, that part which is x minus x bar is right there, and that should be absolute referenced, okay, and that difference must be squared, divided by, that is SSXX, which is that, and that must be absolute referenced as well. Okay, so that is our standard error. Now margin of error is the t-table value, and that must be absolute referenced, times the standard error. Okay, so now lower limit is the forecast minus the margin of error, okay, and then forecast plus margin of error is the upper limit. Now let's okay, now we copy that. That gives us the prediction for the holdout sample. Now we can use the point forecast and the actual value, okay, to find the forecast error measures. So this will be MSE, okay, forecast first, actual value first, comma, the forecast. This will give us the mean square error. Okay. Next is RMSE. Okay. RMSE. Okay, and then MAE. Okay, right there. Okay. Then MAPE. Okay, right there. Then MASE. Okay. So here we have the actual values and the forecast. The third parameter is the random walk forecast, which would be the actual unleaded price 1 month before. So we have to go down to the holdout sample. Okay. So the forecast now start from 1 month before the beginning of the holdout sample, and that's the reason why I added the December 2008 here, so we will have a continuous range of values. So starting from December 2008 till November 2010, so one period before. Okay. And that will give us the MASE value. Okay, and then Thiel's U. Okay, there it is. Okay, so after all this, it looks like, at least in the holdout sample, the random walk does a better job of forecasting the price of gasoline per gallon than these complex, simple exponential smoothing, than this simple regression model. So this tells us the baseline compared to the random walk model. But this is the procedure that you will go through. So you have an estimation sample, then estimate your regression parameters, apply it to the holdout sample, and then check out how well the procedure is doing compared to random walk. Now let's return to the Word document. Okay. Now there are a couple of approximations that we can do. So if n is really large, then instead of going through the computations like what we did now, you can develop a prediction interval for an approximate prediction interval. Simply take the point forecast and do plus or minus 2 times yes. So that will give us an approximate prediction interval. So when n is large, okay, this approximation will be reasonably good. The 2 here stands for 95%. So instead of 1.96, we use 2. Now instead of all this, we use simply the s alone, because as n becomes really large, this factor comes very close to 1. So this will work. Another thing we can do, if y is all positive, and in usually business forecasting like sales forecasting, price forecasting, demand forecasting, y will always be positive. So if that is so, you can use s over y bar as the margin of error. So margin of error is t times sc, all of that. Okay, we can use that as the margin of error. Okay. Now one last concept that we need to cover is, what if you want to forecast more than one period ahead? So we looked at one period ahead. What about 1 period, 2 periods, 3 periods, 4 periods ahead? Okay. Generate forecast for x and apply it to the original model. So what will be the x value? N plus 1. What will be the x value? N plus 2, N plus 3, and so on, and then compute your forecast. Of course, we've already discussed this. So when we have to estimate forecast x also, the forecasting error becomes unpredictable. The uncertainty in forecasted x is not, we are not taking that into account. So we may get an artificially, something that seems very accurate, which may not be very accurate at all. That's the disadvantage. Of course, advantage is, if you don't have to forecast, you can look at what if kind of analysis, so make up values, possible values, reasonable estimates for x, and for a range of possibilities for x, and then come up with forecasts for each possible value. So you can do a what if type of analysis using this approach. Now another approach is to reformulate the regression model itself. We actually did 1 period lag, right? So crude oil of this 1 month is paired with gas price the next month. So you don't have to predict crude oil for the same month to figure out the forecast for gasoline. So instead of 1 month lag, we can do 2 month lag and 3 month lag, and that way we can forecast several months into the future having firm x values without having to forecast that. Now of course this becomes time consuming. For each lag you have to develop a new regression analysis model, and also the more lag you introduce, the less reliable it will be. So maybe the crude price has an immediate effect only 1 month later, okay? But 2 months later, maybe not. So the lag itself may not be a very accurate way of associating the y value with the x. So that's the disadvantage, time consuming and tedious. It may not be accurate also. Okay. So that concludes the simple regression. So we will take these concepts and extend it to multiple regression, where we have more than one x and several x's.